Okay, this video actually did not record the audio for some reason, so I'm going to try to narrate it after the fact. As you recall, when in the end of the last video, the waveforms for the H and V were completely out of balance. I mean, there was 20 dB difference between the two, and nothing I could do by just pressing uh, buttons on the surveillance screen could ever recover it. So I actually rebooted the MRP, and this is where this video starts. As you can see, this is the default state that it came up in, and it's really in a strange state right now. You'll see occasionally the data just gives a little bit of data and then pauses. A little bit of data pauses. The angles are not coming up correctly, and again, this is just doing nothing more than rebooting the MRP. I haven't actually restarted Edge yet. You can see the LEDs on the DSP status are not all copacetic yet. We have a socket error. So I'm basically just sitting here waiting for it to, um, you know, reconnect, if that's even possible for it to do. I'm just kind of moving the cursor around, talking about the waveform right now. You can see we're in the 100 microsecond mode, but the waveform that's displayed is certainly not a pulse compression waveform. So obviously the Edge and the MRP are not communicating yet. Uh, Again, you'll see a bump in the data every once in a while. So put yourself in a situation in the field. You're kind of you rebooted your MRP, and this is what they're seeing, and they're trying to explain it to us, and we're trying to understand what they're saying. Now, the only thing I can say good about it is the level of the signals looks to be more balanced now. So at this point, I'm just trying to do anything I can from the surveillance screen without having to actually uh, go behind the scenes and do anything to get everything going. I've tried selecting 2 microsecond mode. That didn't help. Um, well, you can see as I move around, I'm going to try to change the gate width. You'll see a little flash of data there. Still no data coming in as it should be. We're in a undefined state at the moment. Still waiting for that socket to go good up there. Okay, when I change the gate width, you can see the length of the data, or the number of bins, or the range covered by the number of bins changed, but it's still not spewing data. It's just sort of sitting there occasionally. But now you can see the LEDs on the DSP are actually showing green, except for the white LED, which we know sometimes can be trusted, sometimes can't. So again, I'm still just waiting for something to happen here, hoping that this is one of those situations where it'll eventually, work itself out and get back in sync. But not looking too promising at the moment. So in this case, most people would look at this, I think, and say, "Oh, there's an MRP issue. You got an MRP problem." So all I'm doing now is I'm actually just going to restart Edge. So I'm just going to use the init D command for restarting Edge. And you'll notice Edge pops up in the off mode. I've not quite figured out why this is different. In the older days, it would just come back up in surveillance mode. But it comes up in the off mode, so I have to actually go and manually put it into surveillance mode, which is what I'm about to do. Try to do. Okay, so I go to surveillance mode, and you can see immediately it comes online. So, so in that case, obviously there was some kind of communication error that was non-recoverable between the Edge and the MRP. And it by default comes up in HLDR mode. I'm going to switch it to SIDPO mode, and now you can see that We're in the 2 microsecond mode, and the pulses are very similar. And I'm going to go to the 100 microsecond mode. And wait just a little bit, and you see it responding quite quickly now. And also, you'll notice that the waveforms are now almost exactly the same amplitude. I mean, there's not this 20 dB spread between the two. Before, when I compared these, and you can go back and look at the previous video if you like, and see it for yourself, but there was a 20 dB offset between these two signals, the H and the V. So at this point I'm thinking, well, maybe, this has cleared up the noise sampling issue as well, but we'll get into that later. So I'm looking at this and I'm thinking, all is good. I'm checking the levels at various ranges and they look like they're well balanced. So at this point I'm actually just talking about the fact that the Z-count value was 30 before. I had set it to a realistic value of or more realistic value of 0. It's still not the right value, but it's at least in the ballpark. And in that case, I think I just offset it by the 30 that we had before, and you can see both signals changed by the amount that I injected it or inserted in the DBZ or Z-count value. They both went up. So that was just a sanity check to verify that they actually the Z-count value is actually affecting both the H and the V impulse compression mode, and it in fact did. Okay, so what am I doing next? I'm figuring this out as I go. Alright, so I'm still just talking about these signals. So now I'm going to go back to 2 microsecond mode just to again verify everything looks copacetic. You see the signals do, and now we can look at the noise values, and the noise values look okay. Yep, the noise value looked good. So now I've got to go through the process of taking a dozen noise samples or so to work this down to what we really consider the optimized noise level. Again, this is the part that the guys on the floor, and it's crazy. I don't like it either, because you just have to hit the button so many times. And see, just now another system happened to be radiating and popped in there, and I've got a noise sample now that pushed my noise level up to 7 point something. So now I've got to hit that noise sample button another 10-15 times, because I've got to get that signal back down. So I've got that, and since it's averaging each time, it takes quite a while to average that little bit of interference that we just got out of the signal and get it back down. Now I know it doesn't seem like this is a big deal, but this is super important for the sensitivity, and just as important for the linear dynamic range. I mean, we're trying to pull 95 dB out of these things, and we're getting a lot of that at the bottom, and if our noise sampling process is not working correctly, then we're going to lose those 2 or 3 dB at the bottom that we're claiming that we can achieve. I mean, we have to have that to hit the 95. So for the next few minutes, you can enjoy me depressing the noise sample button. I think in this case, since we're not starting from 100, it's going to go relatively quickly. But again, you can see, you have to push the button every time to get a new sample, and every sample takes a couple of seconds, and so if you've got to push that button 10-15 times, you're looking at a minute. So, and probably to get it down by 1 unit 10-20 times. So if you're off by 10 units because you've got an interference, signal interfered with your noise sample, then you're going to be sitting there pushing that button probably 100 times to get it down to where it needs to be. And you can manually type a value in there, but it doesn't override the real value that's stuck off in memory somewhere, because as soon as you know take another noise sample, I mean it it doesn't take what value you put in there as the noise value and start from that value. It will just simply write over that value and continue sampling, averaging, and sampling. All right, looks like I'm getting close to what what I would consider optimized noise. You can see we got about a one-to-one grass noise to what noise to signal to noise, or really just a thresholded grass. Looks good. So at this point in the 2 microsecond, everything looks pretty good. Alright, so now I'm going to just switch over to pulse compression mode, and as you can see, these signals look quite a bit different now. They are well balanced, and have pretty much the same waveform applied to them. But when I take a noise sample, weird things happen. You can see the H channel noise value is reasonable, but the V channel noise is just some outrageously high number, even though, as we saw, the signal level itself is almost exactly the same. Almost exactly the same. So at this point I'm just setting the values back to 0, so you can actually see that the signal levels are the same. And you can see there's no, interference that's occurring or going through there that would throw these things way out of kilter. I mean, just look at the amplitude of the scale. You can see they're almost exactly the same. So there's really no reason not to expect the noise level to be the same either, as well, I should say. So I'm just putting a cursor there so I can actually look at the values, and they compare within 1 dBz or so. So now I'm looking over here, and I'm just going to change the gate width just to see if that has any undesirable effect. And as you can see, it did have an undesirable effect. The data simply stopped. So we wait, and keep in mind, I've not really done much. It took what 10 seconds for it to finally update, and now we start to see that the waveforms are taking on different shapes. Again, this could be part of the pulse compression waveform optimization that Ching has done. I don't really know exactly how this works, but as you can see by just changing the gate width, the actual look of the waveform itself changed significantly. So again, I'm back to looking at the noise sample. As you can see in the picture, there's a huge difference between the two. H looks relatively normal. V, super big number. Super big number. So I'm now I'm just talking about how many times, literally thousands of times, it would take to work that down. Now you recall in the previous video, I ended up having I experimented with setting in manual values, and I was able to find where the noise level started to threshold. And in the previous example, before I rebooted both the MRP and Edge, the H value was around 20 by a 30, and the V value was, a huge number. It was probably, I think I finally ended up going to up to 400 before we ever saw any thresholding taking place. So in this case, I'm just I'm going in here to set the range, just to see what effect it has on the waveforms. And as you can see, there's a fairly significant delay between the time that I do something or make a change between the time we actually see a response of the system. So again, doing a lot of waiting. And like I said, it's so sad because I think this, is happening a lot on the floor, and things like this are just getting sort of ignored. Okay, so that was another 30 seconds waiting for it to actually respond, and as you can see, the waveforms are slightly different, and I know I keep pointing that out, and it may not even be an issue, uh, but it's just something worth noting. So now I'm going to change back to the other gate width, and again there'll be a delay here. Excuse me. It is 3:49 in the morning. I just hope you guys actually stay with me and watch this so you can experience what I'm talking about and see how important it is that we have somebody, really sitting in front of this stuff trying to figure this out. Alright, so at this point I'm going in to change the range. I believe I'm going to try to go to 120 kilometers here. Okay, I got the error message there because I tried to go to 120 kilometers at a narrow gate width. It's basically telling me I can't do that. Even though when I rebooted it, by default it came up at 120 kilometers, it didn't give the error message. But when I tried to actually, you saw me switch the gate width earlier, and it didn't give me an error message. But when I tried to change the range, it did in fact give me the error message. So anyway, again, I'm just pointing out the difference in the signals here. And I'm going to go in and I'm going to change the range. Out to 120 kilometers. And again, you can see the signals. And when you radiate, they actually, there's some magic occurs, and they, these oddities, or the variances between them, actually goes away for the most part. And this is the part, I guess, that we still need Ching, to log in and do. I mean, this is the magic that's done to get these two different looking waveforms to actually end up looking exactly the same when you radiate and are gathering data is pretty interesting to say the least. Alright, so what I'm doing now is I'm bringing up the screen, and I'm actually just restarting Edge, because I want to show you the effect it has on the waveforms. Now keep in mind, I did not radiate yet in any of this scenario. I've simply rebooted, brought it up, showed you the initial waveforms, which were exactly the same, changed the gate widths and range and things of that nature, and you saw how the waveforms ended up looking different. So now we're going to restart Edge, and we're going to take a look at the waveforms and see what happens. So by default, Edge comes up in HLDR mode, so I have to switch to zip-bulb mode here. And we're also in 2 microsecond mode, and as you can see, somebody is radiating, but the two waveforms for the non-pulse compressed mode look just like what you would expect. I should say the receiver signal. It's and note the range over there says 120 kilometers, by the way, even though the data is certainly not going out to 120 kilometers. There's no error message saying that, it's obviously truncated down. Alright, so now I'm going to go to 100 microseconds. And again, keep in mind, all I've done is just simply rebooted Edge. And you'll notice now the waveforms are miraculously back to looking identical. I did not radiate. All I did was change gate widths and ranges. The waveforms distorted, looked different when I did that. I restarted Edge. Now we're back to the two waveforms looking pretty much identical. I'm going to change the gate width again, and immediately you can see the difference that occurs. I'd just like to reiterate that I'm not pointing out this as a problem. I'm pointing out it's just something I don't understand. This again, now it's giving me the error because I've tried to put in a gate width that when the math is calculated out, it's telling me that range there's just not enough gates. So again, just sort of, I know we're getting redundant at this point, but and you'll actually, do you notice the response time now is actually quite a bit better? I mean, we're not seeing these lags between me changing something and, it taking 10, 20 seconds for it to respond. It's pretty much responding immediately. Even though the waveforms look different, they are actually, coming back fairly quickly. And again, you can just see by virtue of me changing the gate widths and the range. In this particular case, you can see it is actually taking a while for it to respond. But I just did this, 150 frames back or a few seconds back, and it responded immediately. But now it's that took a good 15 seconds. Never saw anything go red on the DSP, but the waveform is now distorted in a different way. And I'm sure I'm jabbering on about the differences between the two, and my lack of understanding exactly why that is. Okay, so now I'm going to go over here and radiate. Now let's just watch what I think that's what I'm going to do anyway. Oh yeah, I'm gonna actually point the antenna, or do a sector scan away from, so it's not pointed into the building. And then I'm gonna radiate it, and we're gonna watch the magic of pulse compression. Obviously, I wasn't quite sure about my antenna angle. I wanted to wait for it to swing around, I believe. Okay. Now that it's swung around, I'll turn on the radiate, and we'll go over and look at the signals. And as you can see, they, even though they were quite a bit different, as soon as we hit the radiate button, the magic happens, and they look pretty much identical. So now we're in a state where I think we could gather good data, but the problem is I didn't really find any, what is that, smoking gun, I guess is the word I'm looking for. I just simply rebooted the MRP and Edge. I couldn't figure out any other way to recover. What's this huge offset? I can't even tell you how the huge offset got put in there between the two waveforms. The 20 dB offset between the noise level of the H and the V being the one that's higher. And even in this case, even though these signal levels look exactly the same right here, um, I believe when I do a noise sample here, you're going to see that there's still some huge difference. Again, the signals themselves look about the same. Let's take a noise sample. Okay, as you can see, the noise sample, even though it yields pretty much the same results in terms of what we see on the signal, I mean, we're still seeing about the same amplitude between the two, and we're seeing about the same signals pop up, above the threshold. But the noise sample value is magnitudes different, as you can see. And again, this is one of those cases, I don't know how many times you would have to press that button, or if you could ever work it down to get it the same level. I think here eventually I will actually go in there and manually put some values in. But, as a user looking at this is really, would be confusing to me. I would be thinking there was some sort of a problem with my receiver, but in fact there's not really a problem with the receiver. So I recall seeing the file that Ching had said something about 23 and 24 being the values that he thought were good noise values. So that's what I'm doing now. I'm just putting in some numbers to get it down to where we can actually see kind of where we're thresholding. And it's a little confusing because the H is at the bottom A scope. So you can see the noise actually is coming up now. Starting to see the grass. I believe that's a value in there of 20 something. It's pretty small on my screen. I can't see it. So now keep in mind when we did this before, the value that I put in for vertical, when we had the sort of wacky waveform, I had to go all the way up to 400 to start seeing the grass levels start to come up. But in this case, I think you're going to notice that I actually have to enter a value that's pretty much the same as the value that we've got in there for horizontal. So again, incredibly confusing. Why was it thresholding at 400 before, or starting the threshold at 400 before, and then in this case, I took the noise sample. It was a huge number. But when I start actually manually entering the noise level just to see where the threshold would occur, if I sit there and mash the button, 1,000, 2,000 times or whatever, and literally it would be that many times. It would be me pressing that button. Each press of the button gives you maybe 0.1 unit of change, sometimes less than that. So if that value is 400 or whatever, and I have to get it down to 20, I'll be pressing that button for a long time. So as you can see, now I've actually got a value in there that's really low, and you can see the noise is about the same now. So what's up with that? Before it was 23 on H or so, and 400 on V to start seeing the grass level, but now they seem to be balanced. But then watch what happens when I take the noise sample. Now we've got a situation where the signals look about the same again. You can see it peeking, poking its head up through there. Threshold is about the same, but the noise values are completely different. Completely different. So it doesn't surprise me in the field when I hear, when I hear from the guys that they're having noise sampling issues, or if we have a customer that says, the noise level seems to change, or there's this odd volume in the middle where the noise level came up. I mean, none of that surprises me. I know this is pulse compression system, there are different rules that apply, but it's I don't think this noise sampling issue is all about noise. Pulse compression. I think this is something that's sort of prevalent across all the systems. Uh, anyway, I believe I'm coming up on the end of the video there. Hopefully this will help us sort it out.